Welcome everyone to the Network Heating and Cooling webinar. The title of today's session is the Circular Economy and Climate Responsive Buildings. I am Dr. Andy Smallbone. I'm an associate professor at Durham, and I'm also the Network Plus lead. This is our last seminar of 2022, and the event has been organized through the EPSRC Network Plus for the decarbonisation of heating and cooling, and is part of a series looking at the different challenges of decarbonising our heating and cooling sectors and behaviours. This month, we are delighted to welcome two speakers from Oxford University who will present their research in low carbon, climate responsive buildings and global production networks for cooling systems. And Giovani is a researcher in sustainable cooling production networks at the Future of Cooling programme at Oxford Martin School. His research has previously focused on developing a tool to facilitate stakeholder cooperation when adopting circular economy principles in municipal solid waste management, particularly in the energy from waste sector. He has also formed part of the Livable Cities team at the University of Birmingham by contributing to the transition towards a circular economy in cities through urban metabolism optimization. His research at Oxford focuses on global production networks for cooling systems, particularly on analysing end-of-life stage in order to situate these systems within a circular economy.
Thank you, Andrew, for the introduction, and thank you for having us here today. It's a pleasure to share our research. Yeah, so as Andrew just introduced me and described my research, I'm currently at the Oxford Martin School Future of Cooling programme. I'm working on sustainable cooling production networks, and I'll talk you through what these are and what I'm trying to do. I'll also talk a little bit about servitisation for cooling, which Jesus just mentioned briefly. As part of the Future of Cooling programme, we have different work packages, and I'm part of the number 4, which is around, again, sustainable cooling production networks. So we're trying to determine and shape the sustainability of how we manufacture and produce cooling, how we move it towards a circular economy, and what are the challenges of addressing that demand for cooling. So because the demand for cooling is increasing at a very high pace, and whilst at the same time we make it sustainable for the environment. Okay, so this is a framework of the Future of Cooling programme, and this is a Nature paper that was published in October 2020. And my work package really, touches upon every single stage of cooling, from the design and production all the way to the end of life. And it really, as I will show, it touches upon all the different levers for change as well. So I will start with first, the first part of the presentation will be talking about a framework that we've developed. We're moving cooling production or manufacturing towards a circular economy. And the second part will be on current research and future work as well. The first bit is why cooling? Why is it important? So we know that over 1 billion people currently are facing a risk of lack of access to cooling. So every year we hear in the news that people are vulnerable to extreme heat, and increasingly in countries where heat has not been traditionally a weather concern, it's becoming more and more important. The demand for cooling is increasing exponentially, so that translates into that it's expected that 10 air conditioners are going to be sold every second for the next 30 years, which means it's a massive amount of air conditioners and resources that go into that. And again, the demand for energy, specifically for cooling, will be equivalent to that of the US, Europe, and Japan combined by 2050. It's becoming more and more critical for human activities, so we're relying on cooling for our food, for our vaccine chains. It's also a great contributor of global warming emissions. Estimations vary from 7 to 15%. And the demand for cooling, again, it's expected to triple, and at some point it will surpass the demand for heating, which contributes to our cycle, right? So the more cooling we use, the more global warming we have, and then the more global warming we have, the more cooling we need. And finally, it is not a symbol of opulence anymore. It's increasingly important for human welfare. So the objective of this review that I've made was to address this question. So what does the literature tell us about the different stages of when we manufacture cooling, and how can we transition towards a circular economy? The objective of the key output was a map of the full system of cooling production using two approaches. First of all, the circular economy and global production networks. And I want to say that global production networks, they're basically the set of actors, not necessarily only companies, but also different actors such as government and other non-economic actors that contribute to the production of a certain good or service. And they're normally arranged around the world. And it goes beyond a bit more than simply a supply chain. So it involves regulations, policymakers, and so on. This review has been published recently, very recently, in the Journal of Cleaner Production. So you can always have a read at it. And yes, focused on active cooling. So we call active cooling, so cooling that requires energy to function. So basically air conditioners, refrigerators, and so on. First, the search strategy. Quickly, I'll go through this. I used literature from 3 different databases using 3 concepts: circular economy, other concepts around cooling, and global production networks, supply chains, and so on. After screening and different criteria used, we came down to only 69 publications that really contribute to how the circular economy can be embedded in the production of cooling. And a map was created. First, the left-hand side talks about socio-political enablers, and I'll talk about this more deeply in a second. And then the right-hand side are the stages of cooling production and the actors involved. Now, first, the left-hand side, we decided to categorize the existing literature on 4 different categories. So first of all, we have policymakers, those who influence directly or indirectly cooling, such as international regulations, such as the Paris Agreement, reaching net zero, the Montreal Protocol, and so on. Technology, that means moving towards super efficient air conditioners, for example, and using low global warming potential refrigerants, and also the use of passive cooling, so cooling that doesn't require energy to function. Then we moved on to business models, and servitisation was one of the important ones, and I'll talk about that a bit more in detail. And finally, consumers, so the end users who are demanding the use of cooling, how they can influence the production of it. Now, on the right-hand side, again, these are the global production networks and the main stages. And the first one, and the first couple were design and production, and how cooling is usually not designed to be easily recovered. Cooling appliances, I mean, so air conditioners are normally not recycled or recovered, for example. They end up in landfill. But that translates again at the management at their end of life. How the production, manufacturing issues, the use of different resources, why different companies decide to manufacture in different countries. The third one is about use. Energy, it's a big player there. Refrigerants as well, and how it's increasingly more important to take into account the leakages of those refrigerants into the atmosphere. For example, I wanted to show this photo of a refrigerator just being abandoned on the street, not far away from where I live. So policy to tackle this, it's important. We sometimes call this zombie refrigerators because they have very dirty refrigerant gases inside them, and they're a threat to the environment just by sitting there on the road. To illustrate this framework, the paper talks about 3 different examples, and I'll just go through one, which is the cold chains. And cold chains are basically understood as the food supply chain and normally the vaccine supply chain. They're the ones that have more literature on there. This is what the framework looks like when considering all the literature that went into it. So we know that there are lots of international regulation that influences cold chains. So the United Nations Sustainable Development Goals have a direct impact on how food is produced and transported, and how it's cold, and it needs to be cold and preserved to avoid any food spoils. And then the vaccine supply chain is very related to buildings. For example, on the right-hand side, on the stages of the use of cooling, how it's transported, how it's used in different hospitals, for example, in warehouses. And there are, for example, other studies by non-economic actors, such as the Environmental Investigation Agency, looking into the leakages of refrigerants in supermarkets, which is a massive threat. I wanted to show that the potential of decarbonizing cooling is quite big. Moving towards a circular economy can help avoid a good amount of carbon emissions. We know that by 2050, the global demand for cooling is going to escalate massively. And if we address these problems now by mitigating them, we can avoid quite a big amount of carbon emissions related to a business as usual scenario. So in conclusion, there are four main enablers that could help cooling productions move to a circular economy. So we talked about policy, how to make it more strict, and how to address the problem of refrigerant gases, so F gases that have very high global warming potential. Then we see technology as developing, so being more efficient. But then there is a trade-off of technology that uses natural gases, but it's sometimes not as efficient as the traditional F-gas technology. So transitioning towards that. Business models, that's mainly servitisation, and I will talk about that in a second. Finally, consumers and how they become more aware of cooling demand and how it's consuming a lot of resources and energy and so on. So there are three main actions to tackle: avoiding raw material extraction. So apart from refrigerants, which is a big concern, plastics and metals are used in cooling appliances, which fall within e-waste. And designing all these appliances to recover those materials, introduce them back into the consumption system. It's really important. We need to eliminate incineration and landfill, definitely, from cooling appliances. They end up being sitting in landfills and having a massive threat for the environment. And then it's a combination of different solutions. Some of them, Jesus talked about them already. It's about cleaning the electricity grid, using low and global warming potential refrigerants, natural refrigerants, and making the appliances more energy efficient. Okay, so I would like to move on to what my current work is about at the moment and what I'm planning to work on in the future. First one is what we've mentioned, the cooling as a service on repeated times. That falls within the business model levers of change. All the phases are involved, all the stages of cooling are involved, but mainly it's the cooling activities or the use of cooling. But it definitely influences all the others indirectly. So cooling as a service, the value proposition falls in making cooling more easily accessible, especially for vulnerable people around the world. And it helps end users avoid, expensive capital expenses at the beginning of acquiring a new cooling appliance. The company that offers the service, the cooling as a service, retains the assets and operates them. So it's in the best interest to use the most efficient ones, the cleaner ones, to keep them well maintained and to extend the performance as long as possible. So that definitely avoids for production of millions of new cooling appliances. The business model could be very similar to a district cooling layout, but the main difference is that this is a business model rather than a new utility. So the research that I'm working on at the moment is, first of all, there are several objectives, trying to gather as much information of cooling as a service development around the world, creating a timeline for that, identifying differences in adoption across sectors and geographies. And one of the uniqueness in cooling as a service is that it works very well. It definitely works in different conditions and different contexts. So, for example, I've interacted with a service provider in rural markets in Nigeria, for example, and the markets are the refrigerators are powered by solar panels, and it works perfectly there because there is no sort of incumbency technology that makes it difficult to transition to this new business model. And it also works well, for example, in Singapore, where you have a massive amount of air conditioners already working there, and companies are increasingly worried about the maintenance costs and the electricity and efficient costs of using so much cooling. I'm trying to, I've gathered a few interviews. So the methodology for this work is gathering interviews across different sectors, different geographies. I have a number of different interviewees, 3 different categories of interviewees. I'm focusing on first of all, the business model approach, how they capture value, how they create it, and then talking about enablers, things that make it easier for the cooling as a service business model to work and be adopted, and also the challenges or barriers for the business model to develop. And by that, those interviews helped shape what is already a barriers index and an enablers index for cooling as a service adoption in different countries. So these indexes, for example, have criteria such as use of energy for cooling per capita. That would be a barrier. So the more energy we use for cooling, it's more difficult to transition to a different kind of business model. For example, another indicator is the share of households that have air conditioners already inside them. How affordable are air conditioners? So kind of the incumbency, seeing air conditioner ownership as an incumbency to transition into servitisation business model. And enablers criteria or indicators are, for example, access to finance, servitisation extent, sales of servitisation business models. And yeah, for example, the sales of business models such as Airbnb, Uber, how service-based business models are kind of adopted in these countries. Disclaimer, this is still work in progress. So these are not final conclusions and not final results, but this is what is mainly expected. And after plotting this graph, I'm dividing it into 4 different quadrants. So for example, quadrant number 1 at the top right-hand corner, we would say that these are countries that have high enablers, but they also have high barriers. These are the countries that I have interviews for. So, for example, we think of Singapore with a big amount of air conditioners ownership. It's a barrier to transition into cooling as a service. Countries that have lower enablers and higher barriers, such as quadrant number 2. So, for example, India and Mexico is a hypothesis is that those countries are the ones more difficult in the transition to cooling as a service. In countries with lower barriers and high enablers, such as the UK, France, and Germany, in quadrant number 4, would be the ones in the best position to adopt this business model. So, in conclusion, that paper, those interviews will help shape and describe the different archetypes of these countries that are moving into cooling as a service business model. But again, this is ongoing work. And finally, future work is about mapping the geographies and intensities of cooling production around the world. It falls within all the stages of cooling or the cooling framework, the future of cooling framework. And it's mainly involving speaking to actors, so mainly the manufacturers of cooling appliances, big companies, and why and how and where, how much they manufacture around the world. And what are the reasons behind it? Is it policy? Is it cheap labor? All this access to resources and so on, access to different markets, etc. That is my presentation. And again, thank you for having us today. And you can subscribe again to our newsletter, follow us on social media. We are happy to be here and answer any questions.
Thank you, Giovanni. Thank you very much.